Ready? Join. Let's open Goodnotes. Programming course 6 and 5. Yes. Well, hello. Now it's time to class. Yeah, please get your seat. Yeah, let's come back to classroom. Well, let's share the screen. Yes. And where's my camera? I'll put the camera here so you guys can see me. It's time to class. Welcome, all of you, to today's class. Please come in, class. Begin. Let's you hear the slides. Last week, we'll get into the 5th chapter. In this chapter, we have learned a lot of concepts about class, how to write a class body. Inside the class body, we have members. The members including the variables and methods. So we have learned something about the methods. The constructors is one of the methods, and I will learn some great feature of the methods. For example, the return value of the methods, the parameter or argument of the methods, and the overloading grammar for Java programming. And today we'll continue the contents in this chapter, and the next concept I will introduce to you is overriding and hiding. What is overriding and hiding means, let's say now we have a class hierarchy. That is, we have a superclass and then have a subclass. And we know this is inheritance relationship between the subclass and the superclass. And at this situation, if inside the subclass we have a method, and this method have the same signature and return type. The first should have the same signature, and next have the same return type. Add this method inside the superclass. So that means we have two methods. One is in the superclass and another one is a subclass. And they have the same signature. What does signature mean? If we say that two methods have the same signature, means they have the same name of method. The method name is the same, and the return value is the same, and the argument is the same. So we name it as same signature. So it's a very important features in Java programming, that is overriding. This concept allows us to write a new version of methods inside the subclass, because we know the superclass have a method and the subclass have the same method. We have two choices. The one choice is do not change anything. Keep the same implementation, that is the same as the implementation in the superclass. It's one of our choice. And another choice is we want to write a new version for this method inside the subclass. So we will write new implementation inside this method of the subclass. That is overriding. So, for example, now we have a class, the name is my class, and we have its superclass as object. As we know, inside the object, this class, we have a method named toString. And inside the my class, the subclass, we define the same method named as toString. So it's the same name as the superclass and the same return type. The return type is string, and the same argument is no arguments here. So the toString method is override the toString method inside superclass. So the toString method inside my class, this is subclass, is overriding the method, the same name, toString, inside its superclass, inside its father, the object. So inside my class, we write a new implementation for the toString. So we write a statement here, return the instance of my class, something, that it's overriding mean. And at the same time, inside my class, now we have toString. This method is overriding the same method inside its superclass. But we also, at this certain times, we can define another toString, another version of toString. But at this time, the toString method is not the overriding of this father. And this toString is another version inside my class. As we talk about, it's the overloading, because this toString, although it has same name as a method inside the father, but the argument is not the same as its father. They have an argument as string prefix, but its father, inside its father, the father class is object. So write it down here. The class object is its father. It's its father. Inside the class object, we have the toString method. But the toString method, the argument is empty, and its return type as string. So inside the subclass, my class, we have toString. One method is totally same as its father. The signature is the same as its father, and the return type is string. Return type is string, as you notice, and the name is string, and the argument is empty. It's the same as its father, but the next toString, the name is the same as its father. The return value is the same as its father, but the argument is not the same. It have the string prefix as its argument, but its father, we don't have anything inside argument is. So this toString is not the overriding of its father. Only this toString is overriding. But how we talk about this toString, it's overloading. So it's overloading. It's overloading. That is, inside the same class, my class, we define different version of toString. This is overloading of toString with another version of toString. And inside this method, we'll use the original version of toString. For example, here, this toString is the original toString, it's a no argument list, and we invoke this toString to print out something with prefix we have defined. So you should distinguish the two concepts, the overloading and overriding. Inside the same program, we have two great features. One is overloading and another one is overriding. And overriding must these features, we talk about these features only inside the class hierarchy. We have subclass, we have superclass, then we talk about the overriding. If the method inside the subclass has the same signature as the method inside its father, we name it as overriding. The method inside subclass override the method inside the superclass. But the overloading, this concept, we only talk about these features inside one class. Inside one class, for example, this my class, and we define different version of a method. So how to distinguish them? Different version. That is, we have the same method name but different argument. So we use the argument to give the different version of this toString method. This overloading. That's a very important concept in this chapter. And next, we'll give you some example here. Now, let's look at example. Now we have a class, planet. planet. Planet of Earth is one of planet, and Mars, Jupiter, all of those planets. And the planet, this method, this class, we define two methods inside it. One is hide, another one is override. Notice that the hide method we mark it static. That is the hide method. Now it's a class method. Class method. It's a very important concept. Class method. This hide is class method because it has a static, this keyword before its return type. So it's class method. But this method override is an instance method. So this is instance method. It's instance method. Okay. So we have two different kind of method inside the planet class, and then we will derive a subclass from the planet. From the father, we have the sun as Earth. So we have Earth as a subclass. So we use extends, this keyword describe the inheritance relationship between the Earth and planet. So the Earth is the subclass and the planet is father, it's superclass. And inside the Earth, the subclass we define the same method as hide, as override. Notice that they have the same name as its father and same return type, all void. And the same argument is empty argument. So this hide and this override is overriding the method inside its father. So then we write another method man. Okay. And inside the main class, we will create an object from the Earth class. So new class with this keyword, new class, a new Earth. We have a Earth object inside the memory, and we use the reference variable my Earth to access it. So this statement, we create object inside memory. Now we have the Earth object inside the memory, and then now we have this my Earth as the reference variable. We put a parenthesis before the reference variable, and inside the parenthesis we put the name of class. This is casting. Casting means we will convert one type of reference to another type of reference. Now the my Earth, the type of my Earth is Earth. The class type is Earth. But the target type is planet, it's father. So it's different. How to do this converting? So we use this casting. We put parentheses with this type to convert the Earth type to the type of planet. So now the my Earth is converted to the type. But this casting, if you want to use it, you must be very cautious about it, because you can convert a subclass type to its father, but you cannot reverse it. For example, now you see a dog on the street. You can see the dog is animal. Yes, the dog is animal because the animal is its father, it's a superclass, and the dog is its subclass. So we can see dog is animal, but you cannot reverse it. Can you see that animal is a dog? You cannot. So you're only allowed to convert its subclass type to its superclass type. So we are now to convert the Earth type to the planet type. Now we have this planet type, my planet, it's a planet type of reference. And now we invoke it hide method, and we invoke it the override method. What happened? The first statement, my planet, we invoke it the hide method invoke the hide method, which method will be executed? Because now the type is myPlanet. And the hide method, remember, we have two hide methods. One is in the earth, hide method. Another one is its father, planet, the hide method. Which method will be invoking? Yeah. Now, if we use myPlanet, use a reference variable because this type is the class type is planet. MyPlanet is reference variable, its type is planet. So this hide method, we will use the hide method in its father, planet. Why? Because the hide method is class method. The market is static, so it's class method. If we invoke a class method, which will decide which method will be used, decide by this type, class type. The class type is planet, so we use the hide method inside the planet method. But the override method is different. It's instance method. So how to decide instance method? We will think about object. We'll try to find this method in which object will give this method to us. At this time, the planet method, the planet reference variable, which object the planet, myPlanet is the reference variable access. It will access the Earth, the myEarth object. So we have the statement myEarth, new Earth. So myEarth is the reference variable to access the Earth type of object inside memory. Although we have already converted to the planet type, but it still point to the Earth object. So this override should be the override method, the instance method inside its subclass. So myPlanet override will invoke the method inside the subclass, but the hide method will invoke the method inside its father, the planet. So it's different. You should understand it. This is the difference between the class method, method and instance method. Yeah, it's different. And then we will go to another concept, that is how to access the variable or method that hiding by the method of a variable inside the subclass. Now I'll give the example. Now we have the class as superclass. Now we have superclass and define instance variable as a variable as Boolean, and the instance method as a method, and then we will have a subclass of this superclass. We have a subclass instance superclass. So now we inside the subclass body we define. Notice we define the same variable, a variable, and same method, a method. Now we know that here this method, a method, will override the method of its father. So this method will write this method in the superclass. And how about this value? A variable. This is the same as the variable inside the superclass. We name it this variable, a variable, hide the variable inside its father. Hide. Now we have a variable as the same as its father. So the variable inside the subclass hide the variable of its father. So the hide. So one question is, if we want to access this method defined in its superclass or the variable defined in its superclass, how we should do? So we should use the keyword as super. So if we use a super dot a method, now we will use the method defined in the superclass. And if we use the super dot a variable that will access the variable defined in the superclass. But if we don't use the super keyword, only use a variable or a method, that is a variable method we define a subclass. So if we want to access items inside the superclass, simply we use the super keyword. That is how we should do. Use super. Sometimes it's very useful because we will use the super use keyword access constructor we define a superclass. Now we give example. Now here's example. Now we have class we define as employee. It's one class. Inside the class employee, we define a name as a string object and the employee constructor. Now it's employee constructor because it's the same name as this class name. And this constructor will pass a string into it because we want to assign the value to its name, to give its name, gives a name for the employee. So we define a constructor employee. And then we will write a new class named the manager. It's a subclass of its father employee. So we extend a manager extend employee. So manager is a subclass and employee is a superclass. Now inside the manager, we define a new variable as department because now employee is a top. Inside the category is a top category and subcategory is manager or worker or something else, right? Something else. And that is the class hierarchy. So inside the manager, we define a department, this variable. And this variable, we want to initialize it inside constructor, how we should do. So we write a constructor inside the subclass manager, the manager, and give the two arguments. One is its name. Another one is its department. So the name, how to initialize the name? So use a super. We'll pass the name to the super and write super parenthesize. That is, we use a super parenthesize to invoke the constructor of its father. So super s, we pass the string to the constructor of the father. So we pass the string to this argument and we give its name. And the department, because the department is this variable we define in the subclass, so we will give its value at this location. So inside the manager, we initialize this department, but its name, we will access the constructor of its father to give its value. That is how to use the super keyword in our programming. If we want to access the superclass, the constructor inside the superclass, we will use a super keyword. It's the future. It's very common because inside the Java platform, we have lots of APIs and several APIs will give us this class. And if we want to give its name, the best way is to use this super, this keyword to access its constructor and give some parameter to its constructor to finish this initialization. So in the future, if we make this code, we'll give you more details about it. And next is about the final, this keyword. The final keyword means if we mark a class, declare a class as a final class, that means this class cannot be subclassed. That means we cannot write subclass for it. Termination for this class hierarchy, finishing, and we cannot extend it anymore. So, for example, now we write a class named as cheese algorithm. This is algorithm for play cheese game. Cheese game. Cheese game. We don't want anybody to extend it because this algorithm have a rule. We don't want anybody to break the rule, so we mark it as final, so nobody can make subclass for our class cheese algorithm. So that's it. But if we only want some of this method inside of class cannot be overridden. That means now the chess algorithm, we can make it subclass. But inside the chess algorithm, we have a class named next move. The next move is a method, very important method, because we define how to move our how play a game, get the next move inside the chess game. So we don't want anybody to rewrite it. As you know, the overriding these features allow us to give a new version inside the subclass. So if we can get a subclass and we can define a new version of a method by overriding. But if we mark this method as final, means although we can define a subclass of chess algorithm, but we cannot write a new next move. We only allowed to use the old version of next move that has already been defined inside its superclass. So that depends on what you want to do inside the program, because it makes your code more safe. If this method is very important, you don't want anybody to change it in the future. So you mark it as final. So it's make it more safer. And if we write a variable, mark this keyword for a variable that will become a constant. So inside Java, if you want to define constant, it's very simple. You put the final, put the keyword before a variable that will become a constant. So a constant, you cannot change its value. When you define it, give its value, and you cannot change it again. So that is a final keyword. And next concept is abstract class. Abstract class, we mark that class as abstract, means inside the class we have the method. We name it abstract method. Abstract method is method without implementation. What is the method without implementation? A common method. When we write a method, we write a common method. For example, now we write a method as my method. Its return type, for example, is we give it a void, and the parenthesize inside its argument we will give it as int a. Okay, and we will have a method body as a brace. Inside the brace, we write some coding inside it. That is named implemented. But if we write a method, for example, it's the same method, my method, and its argument is, but we don't have the class body. We only have the same column. That is no implementation. We don't have the method body. There is no implementation. If a method is no implementation, that means it's abstract method. So we should mark it as abstract because it has not been implemented. There's class, abstract class, and abstract method. If inside the class we have one or two or more abstract methods, this class become an abstract class. If a class has become an abstract class, that means this class we cannot create object for it because it's abstract class. There's something inside it, some method inside it has not been implemented, so we cannot make object based on this code of class. That is abstract meaning. And this concept, this grammar, where we use them for our code, it's very important concept inside Java to use this abstract class and abstract method in the designing step. For example, now we will make a graphic object system. A graphic object system. Inside the system, we have all kinds of different kinds of geometric objects. For example, rectangle, triangle, circle, line. A lot of different graphic objects. We put it inside it, and all these objects. Now we have, for example, I have four kinds of objects: rectangle, line, bezier, and circle. And if in the future we want to extend this system we want it extendable, we will increase this object. We will put new object inside our system. We will put object, for example, inside the future. We have X. It's a new kind of graphic object. We want to put it into our system. Put it in our system. Yes, I will extend this 9. It's 9. Well, now in the future, we have an X object. We will put it inside it. How to do? So, as we know, this object, this rectangle, circle, or something else, we have something that is fixed. That is cannot be changed. Inside the future, the still cannot be changed. Which method cannot be changed? Move to. The move to method inside our current editing system, we move the graph object from one place to another place. Just move to. The move to, and each object we have a point. For example, a circle. A circle, we have a point. This is our coordinate system. This x-axis, this y-axis, and now we have a circle. There's a circle. Wow. There's a circle and this point at the center of the circle. And if we want to move the circle from this place to this place, how we do? It's simply we change the center of the circle now from the x and y. For example, now x is 2, y is 1, and we will move it to this new location as -1 is a new center. So we simply change this center from 2, 1, its position, to -1, -1. So we use move to method. So move to method never changes for any object in our system. A line, a rectangle, always we have a point, and if we want to move it, so we change the position of x and y. That's okay. But which method will change in the future? The difference is different from each other because we have different graphic object that is draw. The draw method must be different because if you want to draw a circle, we have a special method to draw a circle. We have a center, so we around the circle, around the center, the same distance, we get a circle. But if you want to draw a rectangle, that is different. If we want to draw a rectangle, we have a point as the top left point. So a top left point, we draw the line, draw the width, and draw the height. We get 4 edges. We get a rectangle. So the different type of drawing method. So the draw method is different. So when you design a graphic object, design the class, we should mark this draw method as abstract method. The AppMap method, so the draw method, now we notice it has no bridge, so it's a method without implementation. It's just abstract method. But the move too is instance method because it's never changing. But draw method always change. Different from this. If this object different, that implementation of this draw method must be different. So we mark the draw method as abstract because the draw method is abstract. So inside the class, we have a method that marks it as abstract. So this class become an abstract class. So we should mark it as abstract. And now we have an abstract class graph object as it's a superclass. And so next step, now we have a circle. It's a subclass of graph object. And inside its subclass, we will give actual implementation for the draw method. Now we have a center, around the center, we draw all the points, the collection of the point is a circle. So we write actual code for it. And at the rectangle is another subclass of graphic object. We write its version for draw method. And in the future, if we have a class as X, it's a new kind of graphic object. Now we give it implementation for draw. So that's it. Now this system is extendable. Extendable in the future. So it's a very important concept in Java. We use abstract to define the architecture to design a system. Okay? So now have a short break. Yeah. Yes. Now we talk. Step 9. No. Camera. It's camera. Yeah. And okay, little. Find it. And let's find it. If I can find it. box here, and I will give some discussion Java machine tutor requirement mechanism Linux demonstrate Java. That Java run demo code paste, right? Prison value for it. Okay. That can be create yeah. Let's see green. Now I want to give some interesting value about Java. Yeah. And we'll share screen. If the share screen will print it as you break time, you can watch it. Now we are me and the screen, and I want to share the screen. Yes, and now I watch your video. It's produced by Java Zone. It's very interesting, and you see about Java virtual machine. Okay.
Now listen, ladies. Listen. This is the entire Westminster Investment Platform. But if you look very carefully, you will see one tiny little detail. There is no fucking platform. It's all ones and zeros nowadays. And that's what we're going to be doing here. Bits and bytes, and it's hardly a fucking byte. Hey, you motherfuckers. Will you stop fucking about that fucking shooter? Anyway, well done.
A group of stupid guys, right?
It's like taking candy from a fucking green tub. All we gotta do is log in, make a transfer to Switzerland, and then we can all fuck off back home and watch the antics photos and t-shirts and whatever else the fuck is on the fucking planet. Security is as tight as the Queen's arm. So I want you all to listen very carefully to what I just say here. Mr. Buster is our man on the inside.
Oh.
He is what we call our Trojan rubbish bin. Now, it's essential that we all synchronize our wristwatch. Mr. Pascal, no fucking checking on fucking Facebook. All right, girls, let's go to work. Now, the main frame is controlled by something called retinal scan, and it will only open automatically. Let's take everything. We're going to have too much trouble with this. What are you fucking laughing? What do I look like, Mr. fucking Bean? Once we're on the
Stupid
inside,
guys.
then we launch to the main frame, and then all the money is ours. Come on, hurry up, you arsehole pirate. I'm coming as fast as I can. Excellent. It's open source. It's open, well, it's good. And you can't step on really. It means it's secure and robust. I thought you were supposed to be an expert on the Java. Lies. I'm just a Java certified programmer. You stole fucking waffle.
So that's good. Well,
With a Java platform, it's amazing, but it still runs at speeds comparable to optimized native code. That's fucking brilliant. This is fucking brilliant. I used to think the computers were just turning up. But something happened that day. I think I found real faith and a passion for more.
Oh well. Yeah, that's it. Is that interesting? Right. About Java virtual machine. Right. So let's well, talking to this, what give you pass thing next time. That's a place about how to make it practice. So next chapter. We use a package that is API for API Java form. It's quite easy for us to use API and if you want to use IDE and it's a really cool Java. Yeah, because just drag and drop. Just drag and drop here and the code will generate automatically. You only need to like a very few code to control it. For example, we will deal with the class of the department to write code for you. Yeah, and this framework will automatically simply drag and drop on but you have to use the Bible. That is, if you write by the hand, it's such a void. So next chapter, we'll name something about it. Well, let's get back to our class. Now we get into the next chapter, interface and packages. And because the packages have already learned it, we learned it advanced in chapter 5. So in this chapter, we only need to learn something about interface. Okay. About interface, now what interface means? It's very important to understand the concept of interface of Java. Where's me? I will find theme talk. No, not theme talk. And camera. Yes, I'll put it here. Let's check, is it okay. And well, you should understand the concept of the interface. So I will give example. I should have a whiteboard. So we add the page after, okay? And at the blank page, now we have a blank page. We will Make it larger enough. Now I will give example about interface. We will know in our room we have a socket, and we use this socket, we get electricity. So, for example, I have TV, and it's TV, right? And TV set, and there's a plug into the socket and get electricity. That it's simple. Everyone knows it. And this socket, where this electricity come from? It comes from the plant, electricity plant, the power supply system. So behind this socket is a huge power supply system, including plant, including the how to transmit this electricity from remote place to our home. So inside our home, now we have this socket, and we will use it socket to get electricity. And if we have this socket, we have to have this standard socket for get electricity. That is plug must have the same shape as this socket. It must be the same. So we have another facilities in our home, for example, the washing machine. And they have the same type of plug, so we use it to get the electricity from the socket. So that the socket will give us the interface. And the power supply system will use this interface to provide power, provide energy to us. So the power supply system use this interface to provide us electricity. So the product service, a power service to us. And this device, the television, the washing machine, and other kind of thing, the computer, will use this interface to get electricity, to get the service. So the power system provides service through the interface, and our device uses the interface to get the service. To get the service and provide the service, we use the interface to do this kind of things. This very important concept. And inside Java, we will use this concept to implement a lot of very important structure for us inside in the future. Now we will give you some example to describe it. Before we get into a real example, we will learn something about the grammar of interface. That is how to define interface inside your code. And if you want to define an interface, it's similar as we define a class. The difference is the keyword. Now we use a keyword as interface, not class. And we have the name of interface. We still use the upper camel case with this rule to give the name of interface. And the interface keyword, and we still use this keyword extend to describe a super interface. We have the sub interface with extend to describe this relationship. And we have brace. The brace inside it is interface body. So it's similar as the structure of a class. And inside the interface body, what we should have, we have the method and constant. we only allow have two kind of things inside the interface body. One is a constant. So a constant, how to define constant? We use the final or static keyword to define constant inside the interface. And the method is the same as abstract method. That is, this method has no implementation. So it's just no without method body. So simply use a semicolon at the end of this interface. So that is the grammar of this interface. And next, we'll give example. Now, let's see. We have a manufacturer, a factory that it will produce cars for us. And this car and this automobile manufacturer will make the car and how to make the car, and it must implement the controlling to the car. For example, we will start the car, we will turn left, turn right, we will reverse it. So this function for a car is implemented by the manufacturers of the cars, of the automobiles. And another corporation is electronic guidance instrument manufacturers. The guidance instrument manufacturers that they use the GPS information to make guidance, to make routes for the cars. There's another software and produced by the electronic guidance instrument manufacturers. And now the question is how to design a system. That is how to make them together. The manufacturers to make cars and the manufacturers to make this guidance device, how to make them connect them with each other and make a car that has installed this guidance system, so the car can make the automatic driving without person on it. So how to design a system? It's the same as our first example, the power supply system. As you know, the power supply system use the interface, use the sockets to provide us the energy. And our device, our facility inside home, use the socket to get electricity. So now we will face the same problem that we will find an interface to make the two systems together. What is a system? What is an interface? That is operate car. Now we write at diagram. It's operate car. Operate car is an interface. So inside UML, if we want to draw a diagram for an interface, it's the same as we draw a diagram for a class. The difference is you should write an interface on the top of this block. And now the operate car is an interface, and inside the interface we define two interface methods, turn and signal turn. The turn left and turn right. A signal turn is when we turn right or turn left, we will give out some signal. For example, some light, blinking light, red or yellow, to indicate which direction we will turn, or left or right. And now we have operate car, this interface. We have turn and signal. This interface is we connect the manufacturer of the guidance system and the manufacturer of the cars. So for the corporation of manufacturers of cars, they must implement the interface. So, for example, the different kinds of manufacturers, for example, Ford or BMW, they produce different kinds of car, and they all have to implement the method we have defined in Apple car. They have to implement a turn method and a single turn method. The Ford corporation is the same. So they implement the method we defined inside interface, inside the Opera car. And now we have the manufacturer for the guidance system. The guidance system, for example, Baidu, Auto Drivers Corporation, they make it and it uses a drive method to control the car. How to do it, drive the car, because although there are different cars, BMW, the Ford brand of cars, they have already implemented a turn and a single turn method. They already implement the interface, so they are the same type. And to drive this method, we will pass the car as object to the driver method. So inside the driver method, we get this car, and then we can use the turn method or single turn method to do something when we drive on the way. So how to write it inside code? So interface operate car. We define two methods: the interface method turn and the single turn. They are all methods without implementation. The interface method, this is how to define the interface operate car with two interface methods. And then for the manufacturing of the car, now we should implement the operator car, implement the method. So we use a keyword implement to describe this class operate BMW. For example, operate BMW is a car of BMW, and it will implement the operate car interface. We use the keyword implements. Operate car is the name of interface, and implements is a keyword, and operate BMW is a class that is implemented into this kind of interface. So if a class has implement interface, you must write the actual implementation for the interface for the method I have defining the interface. Inside the interface, I have already defined two kinds of method: turn and signal turn. So inside class operate BMW, we have give its implementation. So we have this brace, we have this method body, and inside method body, we must write code to implement the turn method, implement the single turn method. This implementation may be different because we have different kind of brand of car. So, for example, the BMW, they have the implementation for the turn method, and the Ford car, another kind of brand, they have a different implementation for the turn method. So different car have different implementation for the method inside the interface. Yeah. This one, why? Int. Yeah. This method define int turn. Int it's a turn value. Actually, I don't know why, because this example is this statement take from this textbook. They give this method as int turn, and argument is direction and radius. For example, we turn right, while radius decide us how big this we will turn right. And int value, I think he gave this return type must turn give us some result. For example, we finish the turn operation. We turn right in the car, turn right, and we success. So it gave us some feedback through the return value. I think it is. Maybe. I'm not familiar with this car operation. I don't know if that maybe it will give some feedback, give some result, and maybe you will use the result to make the next step. Turn right and give some result and make sure we have turn right directly, and then we can do the next step. Maybe, I think. It depends on the implementation of the car. Okay. So the operate BMW, this kind of car already implement operate cars this interface and gave this implementation for the method which defined in the interface. Now we go to this driver, the guidance system. Now the guidance system, for example, the Baidu auto driver, and this class, it will use the GPS information to drive the car. How to drive the car? We must pass the car to it. So we use this argument, operate car. The operate car is interface name, and OC is a real object of a car. Why we can pass a car to the driver as a type of interface? Because we have implements interface. So the car, the BMW, now its type become the type of interface, the type of operate car. So we can pass it to the drive method. So we pass the car to drive method. Inside the drive method, we get a car, get the object. So once we get the object, we can use this turn method. Turn left, turn right. Inside drive, because the drive in the method, they have information of the GPS, of the location. So it uses location information and decide the route, the car driving. So he decided the route and then he used this turn or signal turn method, so make the car go forward, turn right, turn left automatically, dependent on this GPS information. That's how this system implemented. So we define an interface. Inside the interface, we define two methods. So that it's the automatically driver manufacturer, the corporation, they provide the guidance service through the interface, through the operate car interface. Just like the power system provide us electricity from the socket on the wall, the same. So the driver or the auto driver manufacturer, they use this interface to provide the guidance service to us. The condition is we must implement the interface. For example, if the car, BMW, we want to make it auto-driven by the Baidu auto driver, we must implement operate car interface and implement the method defined inside the interface. So we can use this service. We can get this service. That is ideal. Let me give you another example. Now, another example is for stock price, retrieving stock price. Try to design an information system for retrieving stock price. There are different kinds which will be informed when the price subscribed stocks change. Now we will get stock price from the clients. As we know, the stock price, where the stock price is the stock company. Stock company, they have the stock sales out. We can buy the stock, we sell by on the market, on the stock corporate company. So at the corporation, at the company, they have the price of the stocks. But if you want to get the price, get this information, what we should do? Now we want to use a client. We don't want to go to the company directly, sit there and watch the big screen to get the stock price. I don't want, it must take us a lot of time to get to this corporation. So we want to sit at home. We stay at home. Now it's client. We have a computer, and inside the computer we have clients, and we use the clients to get the stock information. Or we walk on the street and have a phone, and we want to use the app we stored in the phone to get the price of stock. So that is what we will design for the system. We use different kind of clients, the computer on the desktop, or an app on our phones, or other kind of clients to get the information of the stock price. How to design the system? That is, we will think about now who provide the service, who get the service. That the stock corporation, stock company, they have information, they have stock price, so they provide the stock price, the information, the service for us. And as client, we will get this information. So we should design an interface between them. Just like we define interface between the manufacturer of cars and the manufacturer of guidance system. It's the same. So we will define an interface for it. Now we define interface, we name it stock watcher. Stock watcher is interface. So interface. And inside the stock watcher, we define only one method, interface method as value change, because we only want to be notified when the value of stocks change. So define a value change method. And all these kinds, if you want to get the information from the stock corporation, you must implement the stock watcher interface and give the actual implementation for the value change method. So we have app on our phone. We have application on our browser, for example, applet. We have other kind of application, and all this can you can get this change, get this notification of this the price change. When the stock price change, they will get a notification. Now the price change, but how to indicate this, how to describe this change, depend on the kinds. Different kinds will give us different results because they have different actual human machine interface was. For example, if we have a computer, we have a browser, because we have a big screen. So the applet, we will talk the applet, one of these applications that are run on the browser. Because we have big screens, so this kind of clients will give us enough information for the change. Maybe they will draw lines for us, to use different kind of graphic object to indicate different color to indicate the change of the price change. And this is the client. If you use a computer, it's an applet, this kind of application running a browser. But if I have a phone, we install an app on a phone because the screen is smaller, so we can give us so many information on a small screen. So only give some digits to indicate the change of the price. And we should notice this architecture is extendable. So in the future, maybe we have different kind of clients. For example, we have the wearing device, for example, glasses, like Google glasses. We wear Google glasses, And if we want to Google Glasses, we have to install a client on Google Glasses. And when price the change, that maybe I will use a color to indicate the change. When the price, when you buy, the price goes up, and maybe the glasses will give me the red light. I will see everything is red, and I know the stock have price goes up and become a rich people. But if the stock every buys the price go down, and the glasses will use a green color to indicate this the drop down of the price, and we see everything is green. So I was very sad because I lose money because the stock price going downwards. So different kind of clients will give us different result for the change of the price for the stock. So this is how to implement this interface and implement the value change method. How to define it interface? The same interface stock watcher and define three constant. So how to define constant inside interface? You must declare it as final. Final, final. We have three stocks: the Sun, Oracle, and the Cisco Corporation. And we have the value changing method is instant method, so this method is without implementation, so we don't have this method body. And this stock watcher interface. Once we have the interface, now we will implement the interface. One kind of client is an app running a browser. We will implement the stock watcher. So stock applet implements stock watcher. And this extends applet we will talk about in the future. If we want to implement an app inside a browser, we will extend applet. And now, because we have implement stock watcher, so we have to implement a value change method. So we write actual code for value change method. So for example, now we define if-else branches inside of code. If the ticker symbol equals Sun Corporation, we do something. If it's Oracle, we do another things. If it's Cisco, we will other kind of things we'll do it. So we give different code for different stock. So that is the value change method. We give its actual implementation inside of class if we have implement this interface. Once we have implement interface, now we have watch stock method. The watch stock method, I have watch stock method, and stock monitor is the object in the stock company. They have information, and use the watch stock. Use the watch stock, so we pass this client. Maybe it's a client of a browser, maybe a client of an app on a phone, maybe a client of Google Glass. We pass this object to watch stock method. And inside the watch stock method, the stock monitor object in a stock company, it will get a client object, so it will invoke value change method. So the code inside the value change method will be executed and give us different kind of result. Okay, that is the same as our automatic driving car. At the same, we implement the interface, and inside the interface, we define the interface method, and we implement the interface method, and we use this interface to build a connection between the stock operation, the stock monitor, and the client. So the stock monitor provide us the service. Which service? When the price of stock change, give us notification. That is a service. If we want to use the service, we should implement the stock watcher interface and implement the value change method. The value change method means if the price of a stock changes, which result the client will give us. We write actual code for it. Maybe it's a graphic, a line, maybe it's a sound or alarm, maybe a color or something else. It gives us different results based on our implementation. So that's the interface, build the connection between the stock monitor and the client. Just like the interface connection, the driver corporation and the car manufacturers are the same. One side provides service, another side gets the service. Through the interface, we get the service. Through the interface, we provide the service. The only thing we should do is design the interface and design the method inside the interface. Okay? And that is how we use the interface. And this is something that if there's some change, this is some change in the interface. Why there is some change? Because we have different demand. As you know, the software, we will update the software because the people have increments demanding for us. The deserve the new function, so we have to update the software. So sometimes we have to upgrade this interface. We want to add new interface method into the interface. For example, now we want to add the current value method inside the stock watcher method. Now inside the stock watcher method, now we have two interface methods. The value change is old one. The current value is new when we add it into it. When we add the new interface method inside the interface, what will happen? That is, all of the class have to rewrite the code because you add a new method in this interface. So all the class that has already implemented this interface have to add the implementation for the new method you added into it. So the browser app in the browser app, the app on the phone, the app in the Google Glasses, all of them have to add the current value, add the new implementation for the current value. Inside the code, now we have to find the source code and add the implementation for the current value. Although maybe we didn't want the new function. We don't want it, but we have to add it into our code. Have to add it in the code. If we don't add it in the code, our class will become abstract class. We can't get object. So we have to add the current value, the new interface method into a code. So it's not a good way for all of us because some of us want a new function, but some of us don't want a function, new function. So the best way to do it is make a sub interface. So we define a sub interface stock tracker. It's a sub interface of stock watcher. We use the same keyword as we get the subclass. It extends, and inside a sub interface, we write the current value. We put the new interface method into the sub interface, not in its super interface. It's very important because once we define a sub-interface, now we have this structure. This class, app, client on the phone, client in the browser on the computer, client in the Google Glasses, they don't want a new function. So they keep unchanged because they have implemented this interface StackWatcher has no change. But now we get a new interface. It's a sub-interface of StackWatcher named as StackTracker. The new method current value has defined in this new interface. So a new client, maybe this client, they want the new function. So this client will implement two interface methods inside its code. So we define two interface methods in the code. We give its actual implementation because you want a new function. But if you don't want any new function, keep the same, keep unchanged. So it's very important for building a software because, as you know, nowadays we are very boring that because not so well is updating very soon. Maybe 1 day or 2 days or 3 days, we give a new version and we have update for it. We have upgrade to new version. It will cost us a lot of time of a lot of traffic, but we have to because they provide a new function. But if I don't want a new function, I cannot do anything. We have to upgrade to new version. So they don't give us choice. We have to do this. Boring, yeah. But to the software developer, they have the same feeling. They don't want it because if a software system, when it's updating, you have to modify a lot of code. It's very boring. But if you only need to rewrite a very little of it, that's good. So that is, in this system, if a software developer will use this structure, that is, for the client that do not want any change, we don't change the code. We don't change the code. We don't need open the source code and give some modification for it. No, we don't need to do it because we don't need the new function. We still implement the old interface. But for a new client, if we develop new client, we implement a new interface and give the actual implementation for the method that added into it as a new interface method current value. So we only need to write the code for the new client, but for the old client, they don't want any change, so we don't want to change it. We don't need to write code. We don't need to write a new version for this code. So it saves us time, saves us money. It's very important. So in the future, if you build a system, use interface, and you want to add some new function into interface, do not add this function directly into interface. You must make a sub interface. Make a sub interface and put a new interface, a new function into a sub interface instead. It's very important. Okay. That's how we should use this structure when we use the interface in the future. So interface, this concept is very important because it provides us a service concept. In today's application, a lot of application based on this concept. Provide service, and we use the service, and we have the interface to provide the service. Through the interface, we get the service, we provide the service. Why we must design an interface between them that make this implementation extendable. Make it extendable. It's very important. Extendable is very important. As this system we can put new kind into a system. The only requirement is we implement this stack watcher method, stack watcher interface, and implement the value changing method. That's enough to get into our system. And in the future, it's the same. So only need to implement the interface and implement the interface method. That's enough for a new class want to get the service. And the old one, do not change anything. You can still stay inside this system. It's very important. That means our system is extendable. It's very important for a software designer. We will design a software. If a software is cannot extendable, it has fixed. That's terrible. Sometimes it's tragedy. It's very for us, a software is if it's fixed for the programmer, fixed to such kind of software system, that's a nightmare because you will, if something you want get some new function for it, you will check each line of the code and try to find which lines you have to modify, which line you have to remove, something you have to add it. I don't want it. It's a nightmare for all of the programmers. Okay? That's for the interface we have talked about in this chapter. Today, that is contents for today. And about the assignment I have give you last week, I don't know if you have tried to do it. The new assignment? You try? You try? Have you got some idea for it? Yeah. I finish it? No, I just try. Have could you write the diagram use UML to describe the class and its relationship? Use UML to draw the class diagram and draw the relationship. That is will have give you on the class. Use them to describe. For example, we have Tom. Or Tom, it's a little story about Tom. The Tom is class, so we define Tom as class, and inside the Tom, we define the variables and methods. Draw this diagram, and we have a Brad. Now we have a Brad. Brad is under object, and we have Magic House. Magic House. We have three paths: Magic House, Brad, and Tom. So we have the three paths, and we will think about the relationship between them. Which kind of relationship between the Brad and Tom, and between the Magic House and Brad, Magic House and Tom. This is very important before you write code, and you should design the structure of your system, and then you write the code. So, I think you should make some review for the classes that I have given before. The second chapter, the fourth chapter, even the fifth chapter, and something. Maybe you can get something about this assignment, get an idea for how to build the connection between these classes. It's very important for you. And the next class, next week, I will give you the answer to this assignment. so you can know how to do it. Okay. Next week. Yeah. Next week, the 9th week, you have a special arrangement. I know. So the next week, not the 9th next week, the next 10th week. The 10th week, when we come back to classroom, we will give the answer for it. Okay. So you still have enough time to think about it. I wish all of you think about it. Although you can't do it, but you think about how to do it, and when I give you answer, now you understand. Oh, it's not so tough, and now you understand how to do it. But before it, you have to try to do it. Okay. Okay, that's for today, and that's the end of the class today. Okay. If you have questions, yeah, that's for today. That's end of today's class. And well, before we end the class, we have make a roll call. Right? I'll make a roll call for it. So I'll make a roll call before the end of class. And now it's 8th week. And then same, I will read the student number. If you're here, please raise your hand. Okay? And 102. Oh yeah, 102 here. 105. 105. 105 is here. You got 105? No. You don't know 105. 105. Measure. Here. No. And 106. 106 here. Okay. And 110. 110. 110. 110. Yeah. And 112. 112. 112. 1 power. 1 power. 112. Yeah. And next 122. 122. 122. Double two. Who is? Good. No. And 125. 125. 125. Oh yeah. You should give. Oh, I didn't do you. And 127. Okay. 128. Yeah. You. And 133. Okay. Oh, that's it for today. So, bye. Bye. See ya. See you next week. Okay. And try the assignment. Okay. Thank you. If you have questions, leave a message on WeChat books. Yes. Goodbye. That's for today's class. Goodbye, everyone. Have a nice week. Thank you all. Yeah.